Okay, two narrow slits are separated by 1 millimeter, so that is our D. D is 1.00 times 10 to the minus third meters, right? Is illuminated by 545, so our wavelength is 544 times 10 to the minus ninth meters, right? Find the distance between adjacent bright fringes on a screen 3.4 meters away. So we can do this. Let's try this. Let's use this formula and see if that works. If the distance is too big, we might have to back off. Okay? All right. So S is lambda d over d, right? So this is d, big D is how far? 3.4 meters away. Okay? And then we're trying to solve for this is little s is right there. Right? Okay, I think we're good here. So S is equal to 544 times 10 to the minus ninth, and then 3.40, and then divided by 1 times 10 to the minus third. Let's see how big that is. So 544 e minus 9 times 3.4 divided by 1 e minus 3. And I'm getting that that distance is 0.001846. Now, is that a small angle? Well, I think so, right? This is 3.4 meters away, and this is 1.8 millimeters. So this is, when we do our little double slit lab, this is pretty typical, is a few millimeters apart like that. So I'm going to go with this, right? So I'm going to say it's 1.85 millimeters. Remember, a millimeter is just 1,000th of a meter, so we go 1, 2, 3, it's millimeters, right? Okay. What angle separates the central bright spot and the fourth order fringe? Uh-oh. Guess we better use this one, but it's going to be a small angle, okay? All right, are we ready for this? I'm going to erase the screen here. So let's solve for that angle, but it'll be the fourth order fringe, right? Okay, so n lambda is equal to d sine theta. N is going to be the fourth order fringe, right? That's 544 times 10 to the minus ninth, right? Equals 1 times 10 to the minus third. That's the 1 millimeter, right? This is our wavelength of light, and then sine theta. It'll be a small angle. Let's figure it out. Okay, so the inverse sine, so second sine of this times this divided by this. So 4 times 544 e minus 9, right? Divided by 1 e minus 3. I'm getting that the angle is a whopping 0.12467 degrees, right? Okay. And then I'm looking at the answer at the bottom of the thing. So this is the angle, right? It's going to be a very small angle. Let's figure out that distance just for kicks, right? And let's see if we can get, I guess I got the wrong answer down there, but it's just for fun. Let's figure out this distance, okay? So again, we'll just use what? Tangent. Here's S, this is D, right? Tangent of theta is equal to S over D. So the tangent of 0.12467 is equal to the distance that we're looking for divided by 3.4. All right, so 3.4 times the tangent of that is 0.00738 meters, or 7.40 millimeters. Now, just for kicks, what do you suppose 4 times this number is? 4 times 0.0185. Hey, that's the same number, right? I get 0.074, right? Okay, so, or 0.00, right? Sorry, put another 0 there. I get exactly the same number. So these angles are sufficiently small that that we can use actually this type of approximation. Not to find the angle, but to find the distances on the screen.